Hello guys, and welcome back to a new tutorial series on Git, what it is and how we can use it to manage a project. Let's take a look at how they describe it. So Git is actually a free and open source software for distributed version control. And distribute means that every member of the project will have a full copy of the project. That's what distributed means. And version control basically means that you're able to keep track of the history, right? Every little step you have done with the project can be tracked. And that's what version control means, which also means that you can always go back and check out every step you have done, right? Every history, you can go back and forth through the history. Git was developed with Python, C, C++. It was released 2005, which is quite a few years before. And it's been used by a lot of big companies like Google, Facebook, or Meta, Microsoft, Twitter, just to name a few, right? So it's a quite nice workflow, especially for programmers. Okay, and let's take a look at what Git can do for us. Okay, the first thing is to record the history. Let's say that we're making a game, right? So we have some initial state, and then we added some animation, some model, right? And then some coding there. So every step here can be recorded as a history and their actual snapshot of the state, okay? And then, which means that you can always roll back or go forward through the history. You can always check out any history here. By checking out, what I mean is you can always go take a look at that particular history and see how it looks like. And you can also, of course, delete a history. Okay, so you can see how this offers a quite non-destructive workflow, right? Because the history are recorded. You can always go back if you did something wrong or you accidentally deleted something you shouldn't. You can always go back through the history and retrieve it. Okay. Now, that's one thing Git can do for you, which is to record the history. Second thing it can do for you is to work in parallel, right? Oftentimes, when it comes to making a game, you will not be working alone, right? You have a team with you, which means you have modelers, animators, and coders. In that case, it wouldn't be like this, or it shouldn't be like this, because the animators could be animating, and the modelers can be modeling, and the coders can be coding, right? And you kind of want it to be able to work in parallel instead of in this linear way. So in this case, then what Git can do for you is for every member of the project, right, can actually create something called a branch, and they can all work on their own branch. So it goes like this. So instead of working in a linear way, you can actually working in parallel, and everyone can have a branch. For example, the animator can be creating an animation branch, working on the animation, right? And then when the animation is finished, then you can merge back to the main branch, which is the final version of the project, okay? In the meantime, the modelers could be doing the modeling, and when they're done with the modeling, they can also merge that modeling done to the main branch, and so does the coder, okay? So if the programmer was coding the player controller, but then down the way somewhere in the process, there is a bug that's really hard to be fixed, and guess what? You can actually erase that history. And better yet, you can also just erase the entire branch and start over. You can see now in this whole time, right, the main branch is intact. The main branch will only be updated when you merge it, right, with a different branch, or merge a different branch into the main branch rather. And that's when the main branch is updated. So even you got back here, right, it's okay. The main branch is still the original main branch unless you merge it. And that's why it's non-destructive. And you can always erase something or start over, right? That's another power of Git. Okay, let's look at it in a visual way here. So let's say that you're working at home on your computer and you have some Git history there, right? And what you can do if you need to now leave home and go to school and keep on working on it is that you can push your Git repository to the server, which will then update the server to have the same history as you. And then when you get to the school, you can log into that computer and you can pull down from the server so that you got the same update, right? And then let's say that you then worked at home, at the school for like a few hours and you got some new histories there, right? And then you can push that history back to the server. So the server got updated, and then you go back home and on your home computer, then you can then also pull that down as a new history. You can see now how the history carries with you by push and pulling to the server and from the server. That's how this workflow works. That's how the Git works on the fundamental level. Okay. Now, of course, this works okay if you're a one-man army, right? But again, we want to work in parallel with other people, and that introduces the problem here. Let's say that you have some, you're working on your own computer at home, right? And you have some history there. However, before you push, because you're working with a team, there could be other people that's already pushed or merged, right? Some new history on the server. So the server looks actually different than you, right? So the server has a different history, and you have a different history here. Just to be more specific, maybe there's a game level that you did something to the level, you add a bunch of VFX to the level, but there's another person who added in a different animation on the level. You can see now how your version of the level is different, right? Compared to the other version of the level, which is could be already pushed to the server. So the server looks different than you on that level. And at this time, right, if you want to push to the server will actually say, hey, no, mine is different than yours. You cannot do that yet, right? Because there is going to be a confliction. So if the server has a different history than you, when you do push, the server will actually reject your push request. Right? What's going to happen is the server going to tell you, hey, you cannot do this. You have to pull down my history first, and you have to resolve the conflict on your end. So at this time, right, in this particular situation, what's going to happen is that you have to pull down from the server first. Whenever the server is different than you, that's required. Right, so I have to pull down from the server, and then on your end, then you have to then make a choice, right? Do you keep the one from the server, or do you keep your history, right? One of the histories has to be the one that becomes the one that you pick, and the other one has to be abandoned or discarded, right? So you make a choice, and that's when you have to talk with the other guy who made the same change, right? Made the same change files, and you two have to decide which one is the one that's better. And then when it's coding, then there could be more flexible. You can actually determine which line in the same file that you want to keep and which line you want to throw out, right, when there's a confliction. Nonetheless, you have to resolve the confliction locally, and then you pick a winner and you discard the other one. For example, now you pick yours and then discard the one from the server. And that's then the one you can then push back to the server. And the server is okay with that because in your history, there is a deletion and there is a pick, right, to which one you choose. The server can accept that. Okay, that is actually the workflow you need to use when you're working as a team. So just put it in a linear way. Here, what you do when you're working with a Git repository is, first of all, you need to pull down from the server, right, first before you push when you're done with certain tasks. And then you need to make some changes, right? And then you pull changes from the others, and then you push. Okay, or to be more specific, I think it would be better said this way. So first of all, you pull it down from the server and you make your changes, right? Before you push, you pull changes from the others. That's right. And then you push that again back to the server. And in the middle, right, when you pull changes from the others, there could be a confliction, like what we see from the previous slide. That's when you solve the conflict before you push it. Okay. Now, oftentimes the conflict will not happen because everyone is working on a different thing, right? You could be working on model 1, I work on model 2, you could be working on animation, I could be coding. There will be very little chance that there is a confliction, right? But then when there is some, then you have to solve it. When there's no confliction, then you can just pull the changes from the others and push it up again. The server wouldn't complain, and you don't have to make a choice on which one to keep because there's no confliction, right? So just to review this again, right? We pull down from the server, make your changes, right? Potentially make a branch and do your task, and then merge it back to the main branch. And then you pull changes from others or from the server, and then you push it again to the server. That's the whole lifespan of your task. And then in the middle, you can solve conflicts when you need to. Okay. Speaking of the online server, there's a bunch of different services like GitHub, Bitbucket, or Amazon Web Service. and a bunch of others too. And then you can see also that there are a bunch of online repositories from GitHub, like Unreal Engine is actually holding on GitHub, and there's a bunch of others, right? And also there are other very popular developers like this one, Yan. He's a fantastic YouTuber. He teaches fantastic C++, which I highly recommend you to look at if you need to learn C++ from the fundamental level. And he has his own game engine, Hazel, which is also also held on GitHub. Okay, and then this is actually one of the projects we did in our senior thesis project called Tiny Quest. You can see the tracking history, right? Every line here is a history, and that's who did the history, right? The date and what is that history about. There you can put on commits notes to those histories, so you know what's going on with that particular step, right? And every history also have a specific hashtag or hash ID there, so you can retrieve it with that identifier. And you can see now there are a bunch of different people working on it, including me here. That's me. Okay. And you can also see how things are branching out and merging back. Every grayish dot is a merge, right? You can see the merge there, right? And merge means you have actually merged your changes, your branch into the main branch. Or it could be merging into different branches. You can merge anything from one branch to another branch, doesn't necessarily to be the main branch. That's when it becomes super flexible and sometimes a bit confusing. Okay, that's the first video, right? Which is talking about the concept behind Git and how it works. In the next video, I'm going to show you how we can actually do it hand-on. Okay, see you guys next time.